Welcome to my presentation, and my name is Ting Tao, and this is my topic. Does climate change really affect the forest fires in Canada? So first, climate change is now an established truth. Like this background image, this is a fire in Alberta. In BC, Alberta and beyond, the forest fires are getting larger and way more difficult to handle. Many studies have also proved that the occurrence of forest fires is inextricably linked with the rising temperature. So these are my objectives. The first, from 1986 to 2021, what are the changes in the number of annual and monthly fire occurrences and the burned area of fire in Canadian provinces? And second, in which zone did the largest forest fires from 86 to 21 occur frequently? And how is the climate change during the months of the forest fire? So for the data collection, I use the software just like this. Climate NA software package to get climate data. I get fire data from Natural Resources Canada's National Burn Area Composite, and some other information on maps are from Dr. Andrew Ham's laboratory cloud file. And I also use R as a main tool for statistical analysis. And this is a summary of my fire data, and the project is based on this table. So next, for the brain areas, many provinces have peaks in the same year or adjacent years. We can see these peaks. And for the number of fire, from 1997, the number of fires began to increase significantly. We can see this point. And regarding the number of fire occurrences by month, the fires occurred in each province from April to September. In June and July and August, fires are the most frequent of these 3 months. The time for larger scale forests to occur is also roughly concentrated in June and July. And this series of graphs depicts the climate change during the fire months. And TAVE means the average of temperature, CMD means climate moisture deficit, CMI means climate moisture index, and TMX maximum mean temperatures. PPT means precipitation. So many values for the mean temperature, CMD, and the TMS of the fire months are positive, meaning that these climate indices are higher than normal for the current year in that month. And the distribution of precipitation and CMD is skewed to the left, which means that in this month, these climate indices are lower than normal years. This mean temperature, CMD, TMS show the upward trend, and while precipitation and CMD show the downward trend. This means that the occurrence of fire is inextricably linked to change in these climate indices. And converting to the same unit makes it easier to observe changes in a response variable, since different provinces have different forest areas. For the number of fire, we can observe that Newfoundland and the Laboratory, Ontario, Quebec, and the Northwest Territories have relatively small annual fires and relatively stable fire frequency during 36 years. And the other provinces have seen a gradual increase in the number of fires starting around the late 20th and early 21st centuries. For the burn area of the fire, the frequency of larger forest fires is relatively high in Manitoba, Yukon, Northwest Territories, and Saskatchewan. So we can get some information from the map. Large scale fire are concentrated in boreforest ecosystem like this area. And so next. So most of large-scale fires are concentrated in boreforest ecosystem. So this is because of the characteristics of boreforest ecosystem, such as conifer forests, which are flammable. Also, the climate condition features. For example, these regions are cold and dry. Some areas are also windy. Then in addition, these regions are also vulnerable to the rising temperature and the falling humidity caused by climate change. So the occurrence of fire is extremely linked to changes in these climate indices. So thank you.